Hi everyone, welcome back, and it's part 2 of the K2001 7.5-digit multimeter repair. Now in part 1 you saw me tear the unit down and we did some work on the analog board. I replaced a few tantalum capacitors, I repaired a few dodgy joints and basically went through a testing process in order we could get the thing powered up, which we did manage to do, including hooking up the digital board and the display, and it powered up quite successfully. So in this part 2 video I want to finish off the power supply mods so that I can then move on to the reported errors, the 400 series errors on the actual unit itself. So what I did after filming the part 1 video, I actually started to look at these electrolytic capacitors here. If you remember in the part 1 video, they were not sitting down properly on the PCB. They were all at funny angles and all the rest of it with some sealant between them. And actually I took one or two of them off just to have a look, and unfortunately the wrong package was used. You could see the pins have been bent slightly just to fit the pin spacing, the leg spacing on that capacitor, and some of them have been a bit damaged as well. Looks like it's had a soldering iron on it or something like that. So I just took the opportunity, I have them in stock, and I just basically pulled all the capacitors and replaced them all with my own ones and with the correct spacing. A mixture of Rubicon and a couple of Panasonics there. And when I was doing that, these two over here, when I took the capacitors off, there's a little bit of damage on the holes and the tracks underneath when I removed the solder, so I had to do a little bit of a repair job on the underside of the PCB there. I can't show you that because it's all hooked up at the moment, but it's all back working again, no problem at all. So what I want to do now is I want to actually test the unit at 240 volts, the big test. Does the automatic voltage detection, 110 220 volt voltage detection work? Well, we're about to find out. So I've taken opportunity as well to put on a couple of heat sinks onto the large 10 watt resistor there, that 470 ohm, and the FET that is coupled to it. So you can see there, because they do run a little bit warm, because they are actually working reasonably hard, those two, in normal operation. And what I've also done is I've hooked up my multimeter here. I'm monitoring the positive BS supply, that 38 volts unregulated supply. And the reason for that is that will reflect directly the output of the transformer. And if there's any problem with running it at 240 volts or 220 volts, it will show up immediately on this positive BS supply. We should see it somewhere between 34 and 38 volts according to the schematic diagram. They call it the line dependent bootstrap voltage, range 34 to 38 volts. So we're all ready to go. I've got my variable transformer dialed up to 120 volts, which we were running at more or less before, so I should be able to monitor the BS supply when I put power on, and we'll see what it is. Now I need to have the digital board hooked up because that's where that control signal comes from that ends up driving that FET on the analog board. So the whole lot needs to be hooked up. So let me put power on, 120 volts, we'll have a look at positive BS. And the front panel's working now, and we've got 38.2 volts. Now you might have seen there, when I first put power on it read 20 volts and then it jumped up. That's just that monitoring circuitry and the control over the supply kicking in. That was bootstrap voltage is first applied and ramps it up to the full output voltage on the secondaries, and that is the 38.2 volts. So let me put power off and we'll let it dissipate, and let me wind it up to 240 volts. Well, I'll go to 220 actually. So there we go, 220 volts. Let me put power on. We've got to monitor that. If I see anything out of the ordinary, I've got to put power off immediately. Now I can't ramp the variable transformer up slowly. I think the power supply is designed to work within a couple of different windows. It's not continuously variable from 100 volts all the way up to 240, for instance. There's bands in there, so I've got no choice but to dial up to 220 volts. That's how I see it anyway. So anyway, 220 volts, looking on the meter here. Yep, so it kicked over 40, then it dropped down to 38. So the relays have kicked in exactly as they need to in order to select the correct primaries on that transformer and deliver 38 volts output on that secondary there. The power supply section looks like it's working. So let me put power off and dial up to 240. That should enable the full primary windings on that transformer. Okay, ready to go. 240 volts, power on. And yes, 38 volts. So it looks like it's all working as it should do. Brilliant. And I'll just let it sit for a while. Front panel's on. We've got the ADCs working off a camera there. I can see that. Numbers jumping around on VDC. We've still got a nice stable 38 volts there. And I've no doubt the plus and minus 15 and plus 5, they'll all be working. Because if the 38 volts unregulated is working, the rest will be working as well. I'll put power off now because I'm going to check the temperature, no heat sinks. Let's power off. And yes, no problem at all. Just very, very slightly warm. Okay, so what next? Well, I think I'll go and change out this capacitor here on the digital board. As I mentioned in the part 1 video, it's a radial capacitor that's fitted when it should be an axial. So I think I'll change that out. So I'll have to disassemble it all, fix that capacitor, and then I think what I'm going to do, I'm going to build everything back into the chassis. I don't want to run the meter and try out that 400 series errors in this state. It's not exactly a nicely encased, noise-free environment when it's sitting like this, so I can't guarantee what sort of errors or not we might get running it like this. So I think I'll just bite the bullet and put it back into the chassis, and if it needs to come out again, so be it. Well, there's the radio capacitor off the digital board. A nice Nichicon, so I'll actually keep that, and I found an exact replacement for the original, same value, so I'll put this on the board. And before I forget, I'm going to replace the fan. As I mentioned before, I've got one from the spare case. Well, there's the analog board half fitted, and can you see the problem? Yep, it's too tall. The 470 ohm resistor that I put on the board is too tall. There must be different lengths available. But very luckily, I do actually have a working one. This one's intact from that faulty analog board. So I'm going to have to swap it out. Well, let's just double check. Original one. 469 ohms. And the replacement one I found, 467. That'll do nicely. Just a way to put the analog board in, and look what I spotted. I don't like that joint. That's on the power switch. It's not moving about, but a little bit pitted and darkened, so I think I'll just link across there just to be on the safe side and resolder those other legs. Right, that's the meter back together again. I even put the case on just to give the error codes as best a chance as possible. So ready to power up. So nothing for it, let's go. Yep, I've got the message on the screen there. I can hear the fan at the back. And yes, we've got something on display. I don't think it's quite as bright as my other K2001, but it isn't too bad actually. So I'm going to leave it for 15 minutes like this, let it warm up, and then I'll run the self-test and let's see what errors we've got. But in the meantime, let's hook up my PDVS2 Mini and let's see what sort of display we get. Is there any accuracy? Does it work at all? Who knows? Right, let's plug it in. VDC. And give it 1 volt. And yes, we're reading a volt. I wouldn't say it was exactly accurate. I wouldn't say it was very stable either. It should be more stable than that. Well, let's set the resolution. Let's go for the 7.5. And there we go. 7.5 digits. Yes, and certainly in my other K2001, I'm sure it's more stable than that. The 1 microvolt there, it just seems to be all over the place. It should be more stable than that. In fact, it's dipping down. It's wandering up and down. You can see it going down to 190 or something like, wow, up to 300 odd. So yeah, it's way drifty. So I'll leave it for another 10-15 minutes and I'll come back and we'll run the self-test. In actual fact, whilst it's warming up, let's just go along the buttons here and see if we're getting any erroneous values despite the fact I've got nothing hooked up. So DCV, that's quite normal, it'll wander like that when nothing connected. AC voltage, yeah. Well, we're getting an overflow there. Not sure that's right. DC current, yeah, way down in the microamps. AC current, yep, same. 2 wire ohms, yep, overflow. 4 wire ohms, overflow. Frequency and temperature. Yes, AC voltage would seem to have an issue. I wonder if the error codes will bear that out. I'm on 20 volts AC range at the moment and I'm just reading 0.01 of a volt there. And if I go down to the 2 volt range, I immediately get an overflow. So it looks like the calibration or something on the 2 volt range has got a problem. If I go down yet further at 200 millivolts, I got an overflow there as well. That's the minimum. So it only starts working, I think, when we're at the 20 volts AC range and above. 750, yep, 750 is the max. So I wonder if the DC voltage has got the same problem. I've got a short and block in across the inputs there. So we're at 200 millivolts range there. Yeah, well, it's not overflowing. Definitely seems noisy even with the shorten block. Yeah, AC voltage seems to be the only one at the moment which I'm immediately noticing an error there. Overflow. Anyway, it's been on for 15 minutes, so let's try the self-test and see what errors we get. Buttons are not that responsive. I think the front panel membranes needing a clean. Built-in test, automatic, run once. There we go, it's off and running. And I can hear the relays clicking on the 400 tests. All tests complete. Right, yes, we've got a 401.1 error, 0 cal, 407 front end, 410 TRMS, 411 TRMS filter, same. Yep, definitely got some 400 series errors there. So next step is I need to look that up and let's see if we can do something about that. Well, off camera there, I might just have fixed it, and it was actually quite easy. So let me just try another self-test here. Let that run through. I need to fix that buttons as well. Here's it running through the self-test. You see the relays clicking again. Yep. Press any key to continue, and that normally lets you know there's no errors. So I can press the key again, any key, and it just takes me back, so there's no errors at all. So what was wrong? This IC here, U506, I was just looking over the analog board again and spotted some dry joints, or what appeared to be dry joints, in a couple of the pins, pins 5 and 6 I think it was, along the top side there. Looked a little bit dry or dodgy, so I just resoldered that 4 pins along the top there, cleaned it up with some IPA and ran the self-test again, and there's no errors. And there is U506 there. It's an LM393 and it's a comparator, and it's part of the input buffer circuit, specifically the AC input section. Exactly what's generating those 400 series errors. So far so good. It's passing the self-test. Now whether that's fixed it permanently, I won't know. So what I'll need to do is run the instrument and just randomly check it every now and then, switch it on, switch it off, overnight, that sort of thing, and just make sure that those errors are cleared. The next thing is it accurate? Well, let's hook up a PDVS2 Mini. I've got it set to 1 volt. It's on auto ranging at the moment. That's not too bad. So let's go up to 2 volts. Yep. And all the way up to 10 volts. Aha. It's not very accurate at 10 volts. So let's do a little test here. Let's go back down to 1 volt. And set the range manually, 2 volt range. So 1 volt coming in, 2 volt range, that's quite accurate. Let's go up to the 20 volt range, still with the 1 volt signal. And there's where we're getting some inaccuracy. The 20 volt range. Try the 200 volt range. That's not too good either. So looks like 2 volt range is okay, but the 20 volt range is out. I think the instrument now needs recalibrated. It'll bring all those ranges into spec. Either that, we've still got a hardware problem. But what about some of the other modes? Well, I've got my HP3245A hooked up now, and I'm delivering a 100 milliamp signal to the 2001, and yes, it's a little bit out there as well, so it looks like current. It could do a bit of recalibration as well, but that all falls under the same procedure. Let's try resistance. For resistance, I do actually have a 20k CADIC resistor. I don't have any proper resistance standards. I really should get something. And I've got it hooked up into the input there, and as you can see, 20k, it's not too bad. I can't remember offhand what the accuracy of that 20k is on my 3458A, but I do actually have a couple of other ones here which I have documented, a 100k and a 10 meg, and I'd actually written on the resistances there at 23.8 degrees C, so we'll try that too now. And first of all, the 100k, yeah, a little bit out, and the 10 meg, yes, that's a little bit out as well. And there's a 1 volt AC RMS signal from my HP3245A, and it's not too bad. And whilst we're on AC voltage, let's just change the frequency around. I've set it to 10 Hz now, no problem there. So let's run another self-test now. It's been on for a wee while. I've still got the case open, so, well, who knows what will happen. So let's try it again. test. And off it runs. Yep, no errors. Okay, that's the front panel removed, because I do want to take the PCB out and just clean up that membrane on the front there and try and improve these buttons on the front there. And there is that beautiful VFD. So I'll use some IPA and just go over these contacts here, and I'll do the same actually very lightly on the back of those little carbon pads on those push buttons. And here we go. A little bit of dirt coming off, as you can see. And I sit back together. Quick test. Yes, that's much better. Okay, and it passed calibration. I've just run through the calibration procedure to see if I get that 10 volts back into spec, and it's basically what you've got to do is you've got to apply shorts, 2 volts, 20 volts, and a couple of different resistor standards, which I've managed to cobble together. To get 20 volts, I had to put 2 PDVS 2 minis in series, because I don't have a metrology grade 20 volt signal. So, but it seemed to have passed anyway, managed to get it done. So there's 1 volt. Now if I ramp it up to 10 volts, and it's not too bad, it's a little bit out. I need to fire up the 3458A to get it more accurate there. Not too bad. So I think we can call this one a successful repair. I will need to run it for a while and monitor the errors, the self-test errors, see if they pop back up again. But I'll leave the unit running 24/7 and we'll see what comes out of it. And of course, thanks to Steve from the USA for sending this Keithley 2001 in. These units are quite complex inside, as Steve found out, and I think I was absolutely very lucky to get away with clearing those errors on the self-test so easily. So thanks for watching, and remember you can always comment down below, and don't forget to like and subscribe. It really does help the channel grow. Links below to my website, and for those who prefer Odyssey, check out my channel there. There's plenty more repair videos on my channel, from the simple to the complex. Check them out, and thanks for watching. Well, here's something a little bit unexpected. It's 8 hours later, the unit's been running most of the day without a problem, and I happened to glance at the display and it was all over the place. And opening up the unit, taking a look at the back of the analog board, and one of my tantalum capacitors that I just changed out in the last video was dead short. Now this is across the output of the positive 15 volt regulator, and it's a 25 volt tantalum, so more than adequate. So I began to suspect the regulator. Now of course, with the tantalum dead short, the regulator was pulled down to 0 volts, hence the readings were all over the place. So took the tantalum off, took the regulator off and tested the regulator standalone, and it was perfect. Now obviously I've replaced the regulator, but I've also replaced the tantalum. In fact, I went ahead and changed out all 3 of these tantalums that I'd previously replaced in the last video. But just to be on the very safe side, I've upped them to 35 volt, and at the same time gone from 10 microfarad up to 22 microfarad. So that should more than cover it. And yes, it was in the right way round. It's actually very clearly marked in the PCB, and checking the circuit, they were the right way round. This tantalum on the output of the positive 15 volt regulator. And one thing I started to be a little bit suspect about is, what is the input to that regulator? Well, it's actually quite low. It's only 20 volts DC. So there's plenty of headroom if the unregulated supply does spike up a little bit. So no idea, just maybe one of those things. The tantalum went dead short after about 24 hours of use, something like that. So let's see how the new ones get on. And there it is, back up and running again. And if you don't see any further updates on this video, you'll know it's okay. Thanks for watching.